Hello and welcome to the 3-6 notes. This is a section about perpendiculars and distance. And the reason why we're talking about perpendiculars and distance in the same section is that we know that the shortest distance between a point and a line is a perpendicular line. Okay, so that's the idea. We can find the distance between lines by creating a perpendicular line. And so I kind of just want to jump in here real quick and talk about number one. And we want to construct the segment that represents the distance indicated. So the distance from point B to the line AC, the shortest distance that we would have is a perpendicular line. And so what you'd want to do is you'd want to draw a line from B going straight down to AC, but you'd want to label that with a right angle. Okay, and that's it. Okay, and you can then create an intersection point here and maybe call that D, and the distance, the shortest distance, is the length from B to D. Okay. Now let's go ahead and take a look at number two. We want to find the distance between point G, okay, and the line EF. Okay, and so I want to construct a segment that's perpendicular. All right, so I'm going to draw a line going straight up, and if that's perpendicular, I'm going to label that with a right angle. Okay. Consequently, you can come in here and call this, say, point H, okay, at that intersection of the perpendicular line and EF, okay, so that's what you got there. Let's come over here to part 3. Now 3 is a little bit confusing because we want to figure out the shortest distance between Q and the line SR, but the problem is if we draw a line straight down, it doesn't actually intersect SR. However, we're talking about line SR. What we're given is a segment on that line. Now what I can do is I can extend this out a little bit and draw an imaginary line going this way, okay? At which point I can then take Q and draw a line straight down from Q, okay, and make a right angle, okay? And we can go ahead and maybe plot a point here, and we'll call that, say, point T. And so that would be the distance from Q to point T, or from Q to line SR, and it intersects at point T. Okay, so it's a little bit weird, but we'll get into this when we start finding areas of these figures and stuff like that, and we'll need to know this distance. Okay, so let's do a little bit of stuff with graphing. Okay. And on question number 4, it says line L contains points 0, -2, and 6, 6. Okay, and then it says that point P has coordinates from -1 to 5. And what we want to do is we want to find the distance from this point P to this line L. So the first thing I'm going to do is plot these points for line L. So I'm going to plot the point 0, -2 here. Okay, and then I'm going to plot the point 6, 6. Now it's a little bit off the graph, so this is the point 5, 5 right here. So 6, 6 is up here. So we just got to deal with that. Sorry, I keep doing that to you, but you know sometimes the graphs that we're given aren't the best. Okay, and so what I want to do is I want to create a line going from 0, -2 to 6, 6. Okay, I'm going to extend that out like that, and I'm going to call this line L. And what I know from this line is I can calculate its slope, okay? So if I went from 0, -2, I'd go up 8 units and then over 6. So my slope here on line L, my slope M, is equal to 8 over 6, okay? And really that simplifies to 4/3, okay? And so if I go up 4, so I go up 1, 2, 3, 4, and over 3, we also have this point on the graph at 3, 2, and I'm going to label that point here at the point 3, 2, okay? Now, what I want to do is I'm going to go ahead and plot the point P at negative 1, 5. So I'm going to come over here and go negative 1, up 1, 2, 3, 4, 5. And I'm going to plot a point there, and I'm going to call that point P. Okay, and what I want to do is I want to draw a perpendicular line from point P to this point here, okay? And so, my perpendicular line looks like it would go this way. Now, what I know about this line is that this line has a slope of 4/3, okay? So I know that my perpendicular slope is going to be the slope of negative 3 over 4, okay? And I'm going to go ahead and calculate that. I'm going to start at point P, and I'm going to go down 3, 1, 2, 3, and over 1, 2, 3, 4. And that intersects at the point 3, 2. So I'm going to construct that line here real quick. All right? And I know that this is perpendicular. And what we're trying to do is we're trying to find the distance of this line here. Okay? That's the distance between point P and the line L. So I know that this is the point negative 1, 5. Okay? And I want to calculate the distance between those 2 points. So I'm going to zoom in here so I can write a little bit neater. The distance that I'm looking for is equal to the square root of, okay, so now I want to do y sub 1 minus y sub 2, so I'm going to do, I'm sorry, y sub 2 minus y sub 1 doesn't really matter. But I'm going to go ahead and come in here and say 2 minus 5, okay, just using the distance formula, plus 3 minus negative 1. Okay, so 3 minus negative 1 and square that. So our distance then is equal to the square root of, this gives me negative 3 squared, plus 3 minus negative 1 is really 3 plus 1, so that's 4 squared. Okay, and so then our distance is equal to the square root of 9 plus 16. So our distance is equal to the square root of 25, and so our distance that we're looking for is 5 units. Okay, so pretty standard stuff on this. But again, it just takes a little bit of thinking, a little bit of, okay, what are we doing? How would we do that? And a lot of it is just your ability to find these points and go from there. So let's go ahead and take a look at, I'm not going to do number 5. Number 5 is kind of tricky to do without having a graph, but I do want to do this on problem 6 and 7 using a graph. You could do this algebraically, but let's just go ahead and look at number 6 real quick, and we'll go from there. All right, so what I want to do in number 6 is graph both of these lines. And so what I know is that this line has a slope of 1 and y-intercept of 9. So I'm going to go to my y-intercept 1, 2, 3, 4, 5, 6, 7, 8, 9. Plot a point there. Okay, and I have a slope of 1. So I'm just going to kind of draw a line here with a slope of 1. Okay, and go up like that. So I have that line. And this line is very similar to that. It has a slope of 1 and a y-intercept of 3. So I'm going to plot a point at 3. Okay, and that is a slope of 1, so I'm just going to draw a line going like that with a slope of 1. Oh dear. Kind of hard to draw sometimes. Okay, let me go down like that. Okay. And so we have these two lines here. And what we want to do is we want to find the distance between them. Okay, now the first thing we need to do is identify the fact that both of these slopes, both these lines have a slope of 1. Okay. And we want to identify that the perpendicular slope that we'll need is equal to negative 1. Now, we can really, this one is pretty easy because it allows us to kind of, do whatever we want as far as choosing points. but we want to choose a starting point. Okay, we want to choose a point on the graph. Okay, choose point on the line. Okay, and it doesn't matter which line we choose. I'm just going to go ahead and choose this point right here. Okay, I know for a fact that that's a point on the graph because it's my y-intercept. And so if I plot a point here at 0, 3, and I'm going to label that point 0, 3, I know that I have a slope of -1 that would be perpendicular. So I'm going to go up 1 over 1, plot a point here, up 1 over 1, plot a point here, and then up 1 over 1 and plot a point here, okay? And so what I can do here is I can then construct a line that goes between those 2 points. And all I need to do now is identify what this point is here, and that's the point -3, 6. Okay, and so now what I want to do is just calculate the distance between those 2 points. And so I'm going to come in here and I'm going to write that my distance, d, is equal to the square root of 3 minus 6 squared plus 0 minus -3 squared. Okay, and so my distance then is equal to the square root of -3 squared plus +3 squared. Okay, so my distance then is equal to the square root of 9 plus 9. So my distance is equal to the square root of 18. Okay, and what I can do here, this is reasonable, or you could say, you could split this up into the product of 2 radicals and say the distance is equal to the square root of 9 times the square root of 2. And so then you get the distance is equal to 3 times the square root of 2. Okay, and we can leave it like that or like this, but if we take this 3 times the square root of 2, we get that the distance, d, is approximately, oops, I shouldn't do equals, the distance is approximately 4.25. Okay, that's approximately the distance between these 2 lines, okay? And that distance would be the same if we had done, you know, the point from here and done a slope of -1 all the way to here, okay? Then these 2 segments are congruent. So you can really choose any point along this graph and then, you know the slope of that, use your perpendicular slope and go the opposite direction and find a location on the other line. And sometimes, guys, it's really not that easy. And so it's important that we, can do this algebraically as well. But, for our purposes, we're just going to go ahead and do it graphically for right now. All right, so now let's take a look at number 7. 7 is we're going to do the same thing we just did in number 6. But I'm going to go ahead and plot these graphs. The first one, I know we have a slope of -2, but a y-intercept of 5. So I'm going to start at a y-intercept of 5 and go 1, 2, 3, 4, 5. Okay. And I have a slope of -2. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And just kind of create this pattern here. Go up 2 to the left 1, up 2 to the left 1. I'm going to go ahead and connect all these points with a line. Imagine that's a straight line. I'm trying my best here. Okay, and then let's do this again, but for the point starting at -5. So 1, 2, 3, 4, 5. Okay, same thing, slope of -2, so up 2 to the left 1. So follow this pattern. Okay. All right, so let's go ahead and connect these with a line. Imagine that's a straight line. Okay. All right, so now what I want to do is, I'm going to locate a point I know that is on the graph. Okay, and I'm just going to go ahead and start here at -5. Okay, this is the point 0, -5. And what I know from my graph is that my slope of each of these lines, my slope is equal to -2. Okay, my slope is equal to -2. So my perpendicular slope, The one that I really need is going to be positive 1/2, okay? And so what I can do from here is I can actually start at 0, -5, and I can go up 1 and then over 2 and plot a point, go up 1 and over 2 and plot a point. And I get this point on this graph, okay? And that's the point 1, 2, 3, 4 down 3. This is the point 4, -3. Okay, and if I draw a line here, this is going to be perpendicular to that. Okay, and we just want to find the distance between those 2 points. So my distance is equal to the square root of -3 minus -5. So -3, and let me write this a little bit better. -3 minus -5 squared plus 4 minus 0 squared. So 4 minus 0 squared. Okay, so then my distance is equal to the square root. Okay, this is -3 plus 5, which gives us 2. So we get 2 squared plus 4 squared. Okay, and so then my distance is equal to the square root of 4 plus 16. So then my distance is equal to the square root of 20. All right, and I'm going to split that up into the product of 2 radicals, and so I get that my distance is equal to square root of 4 times the square root of 5. Okay, square root of 4 is just 2, so we get that the distance is equal to 2 times the square root of 5. Okay, so this is an answer. This is your simplified exact answer, and we can get an approximation for that. And so we know that D is equal to, or I'm sorry, approximately, okay, distance D is approximately about 4.47 units. Okay, so we are doing some heavy computation here. We're integrating, the coordinate plane, and algebra, and formulas that we've learned. So it's all kind of coming together, guys. So I hope that you enjoyed this video. I hope that you learned something from it. So we're gonna go ahead and stop and go ahead and get started on the homework, and we'll see you later. Thanks. Bye.